Hi, welcome to my channel. So in this video, I'll show you how to find the eigenvalues of a 3 by 3 matrix. But before you do that, please subscribe to my channel, like the video, share, and comment what you think about this video. Then don't forget to turn the bell notification. Let's get started. So what do we have here? We have matrix A, and the question says find all the eigenvalues of the matrix below. So all the eigenvalues, because this is a 3 by 3 matrix, so there are 3 eigenvalues in this matrix. First step, the formula. Quite simple. So in our case, we have A. So the formula will be AX minus lambda I is equal to 0. A, this is matrix A there. X is for the eigenvectors, then lambda is for the eigenvalues, then I is the identity matrix. So in our case, since we are looking for the eigenvalues, so we're going to ignore X for now, for this video. So rewriting this formula, without X, it will be A minus lambda I is equal to 0. So we have to multiply lambda with the identity matrix. Now, the format of the identity matrix of a 3 by 3 matrix, if you've forgotten, it looks like this. So we have 1, 0, 0, 0, 1, 0, 0, 0, 1. So we have to multiply lambda with each of these entries there. Now we know that whatever number we multiply by 0, the answer is always 0. So when we multiply this with lambda, we're going to have something like 0, 0, 0, 0, 0, 0. Then this diagonal here will have lambda, lambda, lambda. So let us write in, of course, with matrix A there. So matrix A, we have 4, 0, 1, negative 1, negative 6, negative 2, 5, 0, 0, minus, when we multiply lambda with the identity matrix, we're going to have something like lambda 0, 0, 0, lambda 0, 0, 0, lambda. Then from here we apply the subtraction of matrices. We follow the corresponding position here. So 4 minus lambda, it will be 4 minus lambda. Then what else do we have? 0 minus 0, it's 0. 1 minus 0, it is 1. 1 minus 0, or negative 1 minus 0, it is negative 1. Negative 6 minus lambda is negative 6 minus lambda. Negative 2 minus 0, it's negative 2. 5 minus 0, it's 5. 0 minus 0, it's 0. 0 minus lambda, it's negative lambda. At this stage that we have reached, we need to find the values of these lambda, because these are the eigenvalues that we are looking for. Now, how do we find these values? Of course, we have to find the determinant of this 3 by 3 matrix. Now, how do we find the determinant? Well, we look at the cofactors of the first entry, the first row there. Now, we look at each of these cofactors and find the 2 by 2 matrix of these cofactors. Now, this is what I mean. Now, also note that as you're looking for the cofactors, you need to follow the rule that says the first one should be positive, then negative, positive, negative, positive, negative, positive, negative, positive. So this will be positive, negative, positive, negative, but we are only focusing on the first rule there. So the first entry there is 4 minus lambda. Then let us form a 2 by 2 matrix here by cancelling this row and this column. So we'll have these 4 there. So negative 6, negative lambda. Down there we have 0. Here we have negative 2. Here we have negative lambda. And of course, the second number here, it's 0. So we follow this rule here. So negative, minus 0, not negative 0. Okay, with the 2 by 2 matrix, we cancel this row and this column. So we're going to have this 2, 3, 4 there, negative 1. Down here, negative 5, then negative 2, negative lambda. Lastly, we have 1 here. We have this 1 there. So remember, plus 1, the 2 by 2 matrix there. We're going to cancel this row and this column. So we have these here. So negative 1. Then we have 5. Then we have negative 6, negative lambda. Then we have 0. Okay, so far so impressive. Next, we need to expand what is in the brackets. We need to find the determinant of what is in the brackets there, but we'll maintain these cofactors that are outside the bracket. So we'll start with 4 minus lambda. Then in finding the determinant of the 2 by 2 matrix, what we need to do there, we get the product of this minus the product here. So the product, so that is negative lambda times 6. It is 6 lambda. Then negative lambda times negative lambda, positive lambda squared. Then minus here to give us 0, because 0 times negative 2 is 0. Let us close the brackets. Then here, because whatever I'm going to do inside here, we know that at the end I'll have 0 because of this 0 here. So let us not trouble ourselves with this one. Just go right straight to here. So on this one we have a plus 1. So here it will give us 0. Then on this one, 5 times negative 6, so this is minus. Then in brackets, 5 times negative 6, that is negative 30. 5 times negative lambda, that is minus 5 lambda. Okay, so we can simplify them further by multiplying what is outside the bracket with what is inside the bracket there. So we'll start 4 times 6 lambda, that is 24 lambda. 4 times positive lambda squared to be plus 4 lambda squared. Then 4 times 0 to be 0, so let us not trouble ourselves on that one. So 6 negative lambda times 6 lambda, it will be negative 6 lambda squared. Negative lambda times positive lambda squared, it will be negative lambda cubed. And of course here this will give us 0, so let us not trouble ourselves on that one as well. So plus, we know that this will make this one will be a positive here, meaning this one will also be a positive. So 1 times 30, it is 30. 1 times 1 times positive 5, because of this to be positive here. 1 times positive, so it will be plus 5 lambda there. So from here we can group the like terms. Of course, we're going to start with the one that has the highest power. So we have negative lambda cubed there. So we'll start with negative lambda cubed, because it's just alone. Now we have these two here which are square. So 4 lambda squared minus 6 lambda squared, it will be negative 2 lambda squared. Then those that have only lambda, we have this one and this one there. So 24 lambda plus 5 lambda to be plus 29 lambda. Constants, we only have one constant which is 30, so plus 30. Then from here, what do we have? We need to multiply the whole of this polynomial with whole of this cubic function with negative 1, so that we end up with a positive polynomial. So here we're going to have lambda cubed plus, this one will be plus, of course, plus 2 lambda squared minus 29 lambda minus 30. So now we need to find the roots that are going to make the whole of this equation to be equal to 0. So what are those roots? So we can think of factors of negative 30. So we can think of numbers such as 1, 2, 3, 5, 6, 15, 30. And these can either be positive, negative, positive, negative, positive, negative, positive, negative, and also positive, negative. So we'll try one by one. So it does start with the positive 1. When we put positive 1 cubed here, it will be 1. Then here, positive 1 squared, it will of course 1. So this will be 1. This will be 2. 1 plus 2, that is 3. 3 minus 29, that is negative 26. Negative 26 minus 30, it cannot be 0. So positive 1 is not one of the roots. So let us go for -1. So when you put -1 here, it will be -1, of course. When you put here, when -1 plus 2, it will be +1. Then here, it's going to be negative here. So when you say -1 times -29, it will be +29. And here we have 1. 1 plus 29, that is 30. 30 minus 30, it is 0. So -1 is what we're looking for. So our first eigenvalue is equal to -1. Now writing this one as, of course, the equation, it will be lambda plus 1 is equal to 0. That's because when we make lambda the subject here, it will give us -1. So we can use this root to find all other roots here. How do we do that? Well, we need to use the factor theorem to come up with the other roots there. So factor theorem, we're going to make this one as our divisor. So we are saying lambda plus 1 to be our divisor there. Then our dividend is going to be the whole of this polynomial. Lambda cubed plus 2 lambda squared minus 29 lambda, then minus 30. So it's quite simple. What we need to do is that we have to divide this lambda into lambda cubed. When you find the answer there, we write it on top. Then we're going to multiply with each term that is here. So let's get started. Lambda into lambda cubed, it is lambda squared. Lambda squared times lambda, it will be lambda cubed. Lambda squared times 1 to be plus lambda squared. Then from here, we subtract so that this one and this one, they'll give us 0. So 2 lambda squared minus lambda squared, it is lambda squared, right? Then we bring the whole of this equation here, the remaining part, which is -29 lambda minus 30. Okay, lambda into lambda squared, it's lambda. Lambda times lambda, lambda squared. Lambda times 1, that is positive lambda. Then again, subtract, right? This one will give us 0. -29 minus lambda, it will be -30 lambda. -29 lambda minus lambda to -30 lambda. Then we'll bring the remaining here, which is -30. Again, we go on. Lambda into -30 lambda, it will be -30. -30 times lambda, -30 lambda. Then from there we have -30 times 1, it's -30 again, minus. Guess what our answer is going to be? To be 0. Now, since we find 0 here, we have to concentrate with what is on top there. So on top we have this. I think this is now a quadratic function. We have lambda squared plus lambda minus 30. So we need to find again the two factors that of 30 that can make this whole equation. When we substitute for lambda, they can give us 0. So I'm thinking of factors of 30. The factors of 30 whose sum is 1, because 1 is the coefficient here. So I'm thinking of 5 and 6. So 6 should be positive, 5 should be negative. So you can write this with using those factors by saying lambda squared plus 6 lambda minus 5 lambda minus 30 is equal to 0. So let us factorize. We're going to factorize this part and also this part. So what is common here? It is lambda. Lambda into lambda squared, it is lambda. Then lambda into 6 lambda, it's positive 6. Here we don't have what is common, but we have a common factor here, which is -5. So we're going to write -5 here. -5 into -5 lambda, it will be lambda. -5 into -30, it will be plus 6 there. So you notice that what is in the brackets are just the same, meaning that we are doing the correct thing. So we just collect these roots now. So outside the brackets, I have lambda minus lambda, this lambda minus 5 there, and then inside the brackets, so just get 1. I have lambda plus 6 is equal to 0. So when we make 6 is alright. I'm in a hurry. Okay, so on this one now, if we make lambda the subject, here you notice that lambda is equal to 5, and on this one you notice that lambda is equal to 6. So these are the eigenvalues that are remaining. Remember, the first eigenvalue number 1 is -1, eigenvalue number 2 it's positive 5, eigenvalue number 3 it's of course negative 6 there, because of course 6 will cross the equal sign there. So you can say therefore lambda 1 is equal to -1, lambda 2 is equal to 5, then lambda 3 is equal to negative 6. So this becomes the solution for this question that says find all the eigenvalues of the matrix A below. So the eigenvalues are -1, -1, then positive 5, as well as -6. So for the eigenvectors, it will be another separate video, but it's not so hard since we've found the eigenvalues. All we need to do is just substitute where there was lambda on this matrix there. Where there is lambda, we put each value one at a time, and then we solve for the eigenvectors. So I'll prepare part 2 of this video. So thank you so much for staying tuned, and of course don't forget to like the video and share. Until next time, bye bye.